This lesson deals with some of the things we've already talked about, but now that we know how to find derivatives a little bit better, it's going to make some of the ways that we solve these a little bit easier. So first of all, we want to figure out if the function is continuous and differentiable. If you remember before, to figure out if it's continuous, you plug a 2 into both of them and see what you get to see if they connect. So when I plug a 2 into the first one, I get 2 squared minus 6 times 2 plus 10. So that's 4 minus 12 plus 10, which is 2. If I plug in 2 in the second one, I get 4 minus 2, which is 2. So it is continuous. Then I want to check the differentiable. So now, because we don't have to use the really long formula, we can check the differentiable easier. Just figure out what the derivative of both of them are. So we have 2x minus 6 on top and negative 1 on the bottom. Plug in your 2 right here. 2 times 2 is 4. 4 minus 6 is negative 2. So it's continuous because the limit as x approaches 2 is 2. But it's not differentiable because the slopes are different. You could say f prime of 2 does not exist. And yes, we've done this before, but it was before we used our rules, so some of the derivatives were harder to find. So I'm just reminding you what will make it easier now that you know how to find the derivatives the short way. So here's another one. We're going to figure out if it's continuous and differentiable. Plug in the negative 1, so negative 1 squared negative 1 minus 3, so we have 1 minus 1 minus 3, that should be negative 3. Plug in the 1 again. I'm plugging in a negative 1, I'm sorry, so it's negative 1. Still get negative 3, so it's continuous. So now we check differentiable, find the derivative of the top, find the derivative of the bottom, plug in a negative 1. Those are both equal, so it's continuous and differentiable since the limit as x approaches 3 is the limit as x approaches negative 1 equals negative 3, and slopes are equal, or f prime of negative 1 is negative 1. Alright, here's another question. Find a and b that makes the function differentiable. So here's what I know. If the function is differentiable, it definitely is continuous. So if I'm trying to make it differentiable, I can also try to make it continuous. So what I would first start to do is plug a 2 in for x. When I do that, I get a times 2 cubed, or 8. And then on the bottom I would have b. And then 2 minus 3 is negative 1. Negative 1 squared is 1. So I have this equation, 8a plus 1 equals b plus 10. But that doesn't really help me solve for a and b. So what I'm going to do is I'm going to find the derivative of each of those two things. And then I'm going to use that to help me with the equation later. So here's on the next slide. If I find the derivative of the top, I get 3ax squared. Plug in a 2, so I get 3a times 4, which is 12a. Okay, the derivative of the bottom would be 2b times x minus 3. Plug in a 2, so it would be 2b times negative 1, or negative 2b. So we already know from the previous slide that AA plus 1 equals B plus 10. And now, because that was continuous, well, now we know these two things are equal to make it differentiable. So we're going to use both of these equations to solve. And what you're going to do is solve for A or B. I'd probably solve for B because it looks easier over in that equation. So I'm going to divide both sides by negative 2. And I'm going to take that and I'm going to plug it in for B. Add 6a on both sides. Subtract 1. I get a is 9/14. Come back here and plug in your a. And if you reduce it, you get negative 27/7, and that is b. So to make a function continuous and differentiable, you start by plugging in the number, set them equal to each other to make them continuous, and then find the derivative, set those equal to each other to make it differentiable. You have two equations to solve, and then you can figure out what a and b would be. All right. We also want to talk about tangent lines and normal lines. Again, because we know how to find the derivative better now, these are a little easier. The tangent lines will be a little bit easier to solve because you don't have to do that whole big long formula. And then normal lines we haven't talked about yet, so I need to tell you what that is. So, for tangent lines, I'd first start with finding the derivative, plug in our x, so at 2, y prime is 4, and that's our m. Here's your x and your y. So to find the tangent line, I'm going to do y equals mx plus b. 1 equals 4 times 2 plus b. So I get 1 equals 8 plus b, subtract 8, and I get y equals 4x minus 7. So there's my tangent line. Not much different from what we did before, except this part right here is much easier. The normal line is perpendicular to the tangent line. So if I ask you to find the normal line, I'm asking you to find the line perpendicular to whatever we're talking about. And what that means is if m is 4 here, that means m for the normal line would be negative 1/4. We have to change the slope. You flip it and you change the sign. We're still going to use the 0.21. So you've got 1 equals mx plus b. Multiply, add, and so your equation for your normal line will be negative 1/4 x plus 3/2. All right, we'll do one more example of that. So we have an x value on this one. We need to go ahead and get our y value. Plug in the 1. That'd be 3 squared, which is 9. And then we need to go ahead and get our slopes. So find the derivative. 2 times 1 plus 2x to the first multiplied by 2, or 4 times 1 plus 2x. Plug in our x value. 4 times 1 plus 2 is 12. So 12 will be our slope for our tangent line. For the normal line, our slope is going to be negative 1/12. Remember, flip it and change the sign. So we've got our x, we have our y, and we have our slope. Y equals mx plus b. Subtract the 12, b is negative 3, so y is 12x minus 3. For the normal line, 9 equals y equals mx plus b. Add 1/12 on both sides. You get 109 over 12, so your equation is y equals negative 1/12 x plus 109 over 12. Alright, another thing that a question might ask you is about horizontal tangents. That is places where the derivative would equal 0. So I'm going to find the derivative here. I get 2x squared plus 3x minus 2. And because I'm looking for horizontal tangents, I want to know where that is equal to 0. So now we're going to factor. Remember, you can multiply, you get 4. Things that multiply to give you 4. I think I'll go back and just do it that way so that you can see it. So that would be a negative 3, let's see. We're finding the things that multiply to give us 4. So that'd be negative 4x, positive 4x, minus 1x, because that gives me a 3x. And I replace that with a 3x. Find the things in common, 2x and a negative 1. So when I factor that, I get 2x minus 1, x plus 2, setting that equal to 0. And I would get x equals a half and x equals negative 2. And both of those places are places where there would be a horizontal tangent line, meaning that the slope is 0. Now, here's another example, finding the places of the horizontal tangents. But this time, it says the horizontal tangents of f of x, and it gives me f prime. Well, if I'm trying to find horizontal tangents, I want to know where the derivative is 0, so I'm setting that equal to 0. You can make it 0 over 1 and cross multiply, or just realize that the top has to be set equal to 0. And so you would get x equals 2. That's the only place that they would have a horizontal tangent line. Here's just some try problems. The first one, figuring out if it's continuous or differentiable. The second one, making it continuous and differentiable, but find out what a and b are. And number 3, finding the tangent line and the normal line of that equation at x equals 5.